Page 122, number 83. A compound contains 47.08% carbon, 6.59% hydrogen, and 46.33% chlorine by mass. The molar mass of the compound is 153 grams per mole. What are the empirical and molecular formulas of the compound? To find the empirical formula, you first divide each percentage by the corresponding molar mass of the element. Divide 47.08 by 12.01 to get 3.92 moles of carbon. Then divide 6.59 by 1.01 to get 6.52 moles of hydrogen. Divide 46.33 by 35.453 to get 1.307 moles of chlorine. Find the ratio for the empirical formula by dividing these amounts by the smallest one, being 1.307 moles of chlorine. 3.920 moles of carbon divided by 1.307 is 2.99, which is about 3. 6.52 moles of hydrogen divided by 1.307 is about 5. 1.307 moles of chlorine divided by 1.307 is 1. The final empirical formula is C3H5Cl. I'll fix the end. To find the molecular formula of the compound, we use the empirical formula we had just found and multiply the subscript of each element by its molar mass. For carbon, 3 times 12.01 is 36.03. For hydrogen, 5 times 1.01 is 5.05. Chlorine will stay at 35.453 because its subscript is 1. When these values are added together, they equal 76.533. Then we divided the molar mass of the compound, 153 grams per mole, by this value to get about 2, which is what we would multiply the subscripts from the empirical formula by to get the molecular formula. The molecular formula of the compound is C6H10Cl2.
Page 276, number 18. The enthalpy change for a reaction is a state function and is an extensive property. Explain.
A state function is a function that only matters that we started at one point and ended at another. Enthalpy is a state function because it does not matter what conditions the phase change happens under, just that it started at one phase and ended at another. For example, if you combust propane on top of a mountain, there will be the same change in enthalpy as if you combusted it at sea level. Enthalpy is an extensive property because its value depends on the mass of the system. For example, if the mass of a gas, smiley face, is doubled, then the enthalpy, flame, of that gas is also doubled.
Page 276, number 19. Standard enthalpies of formation are relative values. What are delta HF, standard enthalpies of formation, values relative to? Standard enthalpies of formation are relative to elements in the standard conditions, being 25 degrees Celsius and 1 atmosphere pressure. 25 degrees Celsius is standard room temperature used for laboratories. 1 atmosphere is standard atmospheric pressure, sea level.
Page 336, number 147. The successive ionization energies for an unknown element are I1 equals 896 kilojoules per mole, I2 equals 1,752 kilojoules per mole, I3 equals 14,807 kilojoules per mole, I4 equals 17,948 kilojoules per mole. To which family in the periodic table does the unknown element most likely belong?
A family in the periodic table is a column or group of elements that each have the same number of valence electrons. The elements in these groups share similar chemical and physical properties. The families on the periodic table are alkali metals, alkaline earth metals, halogens, noble gases, and transition elements.
Alkali metals are located in group 1A. Alkaline earth metals are found in group 2A. Halogens are discovered in group 7A. Noble gases are seen in group 8A. and transition elements are located in groups 3 to 12 of the periodic table.
Boarding. Located below the periodic table are the lanthanides and actinides. Ionization energy is the energy it takes to remove an electron from an element. For successive ionization energies, it takes more energy to remove the second electron and even more to remove the third, and so on. When you look at the given successive ionization energies for the unknown element, there's a noticeable jump between I2 and I3. 1,752 kilojoules per mole goes to 14,807 kilojoules per mole. Since the big jump between the ionization energies are found between ionization 2 and ionization 3, you can infer that the unknown element has 2 valence electrons, since the first 2 electrons are easily removed, the first and second ionization energies. Each of the families in the periodic table have a specific amount of valence electrons found in the elements located in the group. Alkali metals have 1 valence electron, alkaline earth metals have 2 valence electrons, halogens have 7 valence electrons, and noble gases have 8 valence electrons. Since the unknown element is estimated to have 2 valence electrons due to the given data, it is determined to be in the alkaline earth metal family in the periodic table.